Just go ahead and get started. Okay, perfect. Hello. Today I'll be talking to you about how we can connect various ALM tools thanks to the Open Services for Lifecycle Collaboration specification, and ALM tools being pretty much any type of tools that people are using throughout the development lifecycle, meaning all stakeholders as well, not just developers, but also managers and eventually customers. And in particular, at the end, you'll have a small demo of the Redmine connector that we have developed and that we have interfaces thanks to the Open Services for Lifecycle Collaboration. Okay. My name is Jean-Christophe Deprez, and my colleague is Dimitri Durieux. We both work at CETIC. CETIC is a research center in Charleroi, 100 kilometers south of here. And we are mostly involved in software projects, research projects at European and regional level. That's about 2/3 of our funding. And the other third, we interact with a company service contract where we help them with innovations. In addition, I am also involved in the ISO, JTC1, ISO, IEC Subcommittee 7, which elaborates various standards on software and system engineering. And among others, one standard that we are, that I will be just talking to you shortly about, just right below here. And the project that got us here is called Naples, and we are developing a platform where we try to help people reuse not only good practices of software development based on the standard ISO 29110, which propose various software processes for small enterprises. That has been adapted and watered down from the traditionally large ones. And secondly, we also, in Naples, we try to help people not only reuse good practices, but as well the software artifacts that they produce during software development, let it be from requirement all the way down to tests, documentation, deployment, and even traditional project management artifacts. Okay, next. So at the moment, if we look at the current status, and that's probably a bit way back, we see that a lot of tools are being used at the moment throughout the life cycle. Let it be for project management, but also for requirement, modeling, testing, deploying, compiling, building, change request tracking. We find that all of the categories have at least a few tools that are getting popular. The only problem is that they don't always collaborate with each other very well. Next. Then, a few years back, a lot of people started to integrate all of this, but you see that the integration happens in silos. So project management tools started to cooperating with each other a little bit, and build automation and build and test automation tools also started to kind of integrate, but not necessarily between project management and build automation. The integration hasn't been so smooth. There was indeed some interesting integration at the IDE level or at the Forge level, as you can see, and the only problem is that they usually are hardwired. So one of these tools say, okay, you can write plugins, and you write one plugin for one tool. And the goal is now to, and we've seen on the next slide, what we'll see is that the big powerhouse such as Microsoft and IBM have developed ALM platforms where they have integrated a lot of these tools together. However, we can, although the adoption is growing, it's still quite slow. Probably one of the limitations is that it's somewhat of a whole or nothing approach. Either you go with all the list of pre-selected tools that I have done for you, but as soon as you get out of that realm of tools, then it becomes a lot more complex to integrate the tool, and indeed, it's you have to spend quite a lot of effort. The only exception being now that there is a move by Rational and IBM around this open services for lifecycle collaboration specification. And you can go ahead and move to the next slide. And before we do the demo and go over a little bit of the OSLC, what is OSLC, let me show you why OSLC is quite useful. And we have developed at CETIC and with our partners in the Naples projects, we've developed the OSLC connector for Redmine. And in this case here, the traditional way is to use Redmine with its user interface. And you can just go ahead and pretty much create bugs, see all the bugs that are there, all the features. Now let's say that you want your customer to have access to this platform, but you don't want to create accounts for them directly in your Forge. So one possibility would be to create an external application where they can interface with Redmine. And Redmine does offer one nice REST API. However, the problem that and therefore you can post REST requests and get information in the XML schema that Redmine has created for you. It also comes with some limitations that comes with this Redmine REST API philosophy, where they view paging, for example, as something that they've constrained. So you can start querying this REST API, and you'll see that it returns at most, I wrote 20, but I believe it's 100 items at a time. And therefore, if you want to deal with that, what we have found is that a third-party tool provider, next slide, created a nice open source little Java REST API on the top, and it handles all these limitations. Now, if we are at that setup, it's quite nice, but we still have one major problem. And on the next slide, what we see is that what happens if we want to change this Redmine. And we say, look, I would like to connect my front-end application to Mantis or to a Bugzilla or to some other type of bug tracker. And now all of a sudden we have to redo the entire work. And this is where really open source for lifecycle collaboration can come and help out. And what we see is that it comes between application, and it is a middleware where it provides a core functionality, and then on the top of it you can develop your wrapper per tool, and all of a sudden your front-end application will send REST requests to the wrapper. The wrapper will then do the transformation needed, query the tool, get the answer back, and ship back all the results in some RDF type of format. And it can be XML or JSON or some alternative atoms, for example, can also be used. Go ahead on the next slide. So overall, what we see is that with OSLC, meaning Open Services for Lifecycle Collaboration, is an open collaborative specification initiative that is led by IBM. A bit before there was one led by some of the Serena people, but it didn't grow because they didn't convince many people to join with the ALF framework that pretty much died in around 2008. And then this is pretty much when Open Services for Lifecycle Collaboration picked up. And if you look who is involved there, you'll see pretty much all big players in many of the different sectors and domains, and such as Oracle, Airbus, Citigroups, GMs, Thales, and even smaller players have a word in there. And you will see that TaskTop, who are the people developing Mylan, the task manager that integrates in Eclipse, are also involved there, and they had developed a while ago a connector to connect via OSLC service provider, OSLC to their backend, and I mean they kept their old ways, but they also now interact with through OSLC. The important thing to remember about OSLC is that the RDF is the structure for the data transport, and For the exchange, you have to post or you have to submit REST requests. So there are various disciplines that are covered by the OSLC specification. At the moment, with the Redmine connector that we are developing, we have used Redmine for change management. And at the same time, we've decided to say, well, Redmine could probably use its tracker to do some requirement management. And so given that Redmine has the ability to customize its issue tracker with all the fields, we could customize it to actually perform some requirement management tasks. But beside these two disciplines, OSLC covers automation, where automation covers the build, the test, and the deploy part of the life cycle. The architecture, which is quite a core part of this OSLC specification, given that if we look at the IBM strategy, the model-driven development approach is really how they envisaged promoting this protocol with their rational tools, modeling tools, providing the architecture management capabilities. Clearly, we have also the test management and quality that can also connect to the measurement and estimation part. And for the reuse in our Naples project, since we are quite heavily interested in reuse, the asset management is also one part that we are looking at and that we want to implement. Clearly, all these disciplines, as I said in the previous slide, they are implemented on the top. They connect tools that achieve these disciplines, and they rely on the core. And as well, there is also a generic reporting package that you can use with the OSLC. So, in OSLC, with the RDF philosophy, all the artifacts created are called resources, and resources have properties. These resources are represented in RDF, so in terms of format, when you receive them back, it will be either RDF XML or RDF JSON, which are somewhat mandatory for if you implement the OSLC specification. The resource exchange is done through the RESTful wrapper. And if we look, everything is a resource in OSLC. So clearly, even at the very top, all the service providers, and a service provider is the wrapper around one tool for one discipline, are listed in one service catalog, which is itself a resource. So you can query your OSLC top level and say, hey, give me the catalog with all the services. And once you see all the services, and we will do this at one point of the demo right after this. And once you see all the service providers, you can select one, and from that service provider, you can query it or act through it and obtains resource from the tools, or actually even create resources in the tools. In our next example, where I will mention the change management, and actually the change request is the type of resources that you create when you do some change management. And if we look at OSLC, change requests have this format. So all resources have a set of common properties, and these are the titles, the identifier, which are mandatory properties, and all the rest are optionals. So you can have them, but you don't have to. Well, they exist. You don't have to assign them values. So and all of that is defined with the people that collaborate in the OSLC specification elaboration, and therefore anyone in the room here can decide to be interested in here and start to get involved in the discussion. Next, so beside the core properties, there are also a set of properties that are specific to a discipline. Here in the case of change management, you will see that the properties of type, which will be used to specify the type of resource that you are creating for change management, which could probably be a bug or a feature, for example. And then we have additional properties such as a close date and a status. There was some heavy debate in OSLC to see how to handle the status. And so the status was made a read-only field, and next to that you can query a bunch of Boolean variable to have a bit more information about the status, and eventually change the status through Boolean variables. Because so many different change tracking tools handle status differently, with different number of internal fields. So that's the best the consensus could be, that could be achieved with OpenOSLC. However, what's important here is that now if you agree, all of a sudden you become interoperable. Next, there are also, every resources can have a bunch of properties that creates relationship with other resources. And as you will see here, there are quite a few of them. Some of them will point to a change request and the related requirements, or the type of other change requests that would be related to a particular given change requests. So that covers the talk here, and now we'll go through a small demo here. And the demo we'll use a first approach where we'll use a GUI part, and with the GUI part we'll go ahead and we'll interact with what I've called earlier in the presentation application, which is the third-party tool that we use, and then we'll interact with the Redmine in the back end, and we will see that we can actually query it. That's going to be the first part. The second part we'll do is we'll create a change request with application in Redmine. And then finally, we'll see, and this is really where open services for lifecycle collaboration is really powerful, is that you can now talk to many different tools and obtain the actual data. And that data that you obtain is not a duplication, and it's not stale, because it comes from the actual source. So when you are a project manager, for example, and you have a dashboard, you get a dashboard from the exact current status that is there. And if information is stale, it's because the one who was supposed to update it did not do it, and it will jump to your eye when you get that information. And so that, for example, will be the third part, where we'll show a small dashboard where we do cover change management, and we also have the requirement management that somewhat comes almost for free, because since we are using Redmine as well, all we had to do is we could share a lot of the code for that. And then finally, after the GUI part, we'll dig a little deeper, and we'll use a REST client to actually show you that what the GUI does. Really, right behind it, what is created is a REST request, which ships information in RDF XML, and then it comes back with the answer. And so we will also do that. So Dimitri, maybe now we can go ahead, and we'll start, and we'll show you the current Redmine status right before the request. And so here, if we are maybe you can, I don't know if it's readable. The point here not being that it should be fully readable, you just see a list of bugs here. This is a sample project. We've created a few bugs in there. And now what we'll do is we'll select the one where I was the author. And this is through the Redmine, and we'll see there are three, in Redmine interface, we see the 3 bugs where that I've created. And now if we can do the same thing through our application, which is the Naples portal in this case. And in the Naples portal, here is our small little query tool where we can just go ahead, and I mean we've already gone to the right area here, and we can just go ahead and select and see that we could obtain the actual 3 bugs here, number 4, 5, and 6. Where I've created, I was the author. Now, clearly this is just, this little GUI and this little search is at the moment not very elaborated, and this is because at the intent it's just almost like a debug sort of information that we've used. The power of OSLC, as you will see, is more in the dashboarding. That we could use that. So now also with the small interface, we can create a new bug. So with the creation, at the moment we've done a reduced also size of it, where we will create a new bug, and just go ahead. This is a super Devoxian bug. And hello world. Go ahead. And so here, this ships all this as XML RDF, and in return, we obtain the result back. And this is identifier 44. And now, if we go back to the to Redmine, we'll see that this new bug has been added. Okay, so this covers the part where we've interacted with small little get information and create one bug. Now we can go ahead and show the dashboard, and the dashboard here is for this exact same project that we had called OSLC test data. And we will see that here we can get some dashboarding for change requests, but as well also below you can have information for requirement management. And if you want to connect different other tools, let's say if you want to have information from Sonar that brings back up some measurement and that you've done, or some quality management that was done through the tests, you can imagine that if you have implemented OSLC connector for these tools, now all of a sudden you can interact and get that in the dashboard. And so therefore the idea is that the more tools will create these OSLC APIs as part of their development process, the easier for them it will be to integrate with other ALM platforms. So that will be quite powerful. At the moment, there is still a few initiatives to do it beside the rational tools and our own, and you see that Myelin has done it. There was an initiative for Mantis that also did that, and some talks with Bugzilla that show this, that they've done it. And clearly with rational, the full suite of tools for the different disciplines all follow this OSLC protocol at the moment. So in our projects, we are targeting now, beside Redmine with TestLink, we are interested in developing another OSLC connector for TestLink. So now that we've done the GUI part, the next part will be to do with the REST client. And so here, this is kind of we dig inside the technology, and what we will do, it's a GET request from the server. At the moment, by the way, this is in our private cloud, so we go through VPN, and this machine is not accessible outside the CETIC. And so here we just did a GET request. Hold on, Dimitri. Can you go back up and show that the content type that we have specified there is application/RDF plus XML. That information is stated in the OSLC specification, and all we did is a GET request for in our particular OSLC connector. And if we go look in the body, what we will see is that the answer will give us. Oh yeah, no, this is not actually, we did a top level request here at this point, and what we did is we have the service catalog, so it's not, we've not queried the Redmine yet, we have queried the top level server OSLC, and in OSLC we have the service catalog that I mentioned earlier, and so here are the few services that we have. We have one for asset, we have one for OSLC test data, and all of those are service providers around our Redmine connector for change requests. And so now if we pick the one here for OSLC test data, which is the one where we have all the bugs, so our service provider here when we use Redmine is the tool, but the project as well. And here in this case, you then now get to what capability this service provider has. And it has query capability, and it has some creation factory capabilities as well. In our case, we will use the query capability, and if we use this URL now as a GET request, we will see, and all of this, by the way, again, this seems a little bit, why are we going through all of this? Well, this is well structured through the OSLC specification, that you have a service catalog that you can query to obtain service providers, and that once you query the service providers, you get its capability, and if you then have you want to perform a GET request, you can just go ahead and get the query capability. And here in this case, when we do a GET on the query capability, we get all the bug requests. And here are they here, and you will see that the last one we had created, which was bug ID 44, is returned there. And if we just query bug ID 44, what we will see is here is what is being returned, and we see that the title that we had created, this is a super devoxion bug, is there. So now this was the GET, and we can do, similarly, we can do the a post request to create a new bug yet. So here in this case, what we need to do to create a bug is we need to post it to the creation factory URL. The bug effect, the demo effect. Okay. So here, again, we go to the service catalog. All right. All right. And with in the service catalog at the bottom, we have the creation factory. And the creation factory URL will allow us to post a new bug to it. And this new bug, we will use the post. And here, we have to provide the data for the bug in the XML RDF format, since that's what we will use. And so here we had created one previous to the to this speech here. And if we post this information, we see that this was sent, and now if we go to Redmine, we will see normally a bug 45 should be created, and indeed it's there. And you see that the body there had this particular title. So what this shows here is that now, if you want to, let's say, use a Maven to do a build and then launch a bunch of tests, and that for certain type of failures you want to create automatically bugs in your bug tracker, you can interact through a Redmine using the OSLC requests, and all of a sudden this helps automate information. And also, because you simplify cross-connection between tools, one of the expectations, at least, that we have is that maintaining traceability among artifacts in projects will be much more promoted, and therefore that these traces will be actually maintained much more easily as well. So that pretty much wraps up what we have presented for you here today, and I hope that I've got you interested a little bit about this open service for lifecycle collaboration specification. Thank you.